Okay, we're going to look at this question here. You can pause it to read it. Okay, so the first question, we've got rho here, and we want to prove this result here. Now I recognize rho as being e to the I 2 pi on 7. Okay, which is the lowest positive argument root of the 7th roots of unity. So what I'm going to do here is I'm actually going to use that fact. I'm going to raise both sides of this to the power of 7. So I'll get rho to the power of 7 is equal to e to the I 2 pi. And e to the I 2 pi is just the complex number 1. So I've just shown that rho is indeed the 7th root of unity. It solves this equation. We can bring this over this side and we can factor. Okay, remember your factorization for x to the n minus 1. So that's what we're going to do here. And now we can see where this result's coming from. We can divide both sides by rho minus 1 because rho does not equal to 1. Just make sure you justify rho is not 1. Okay, this complex number originally is clearly not 1. So that's part I done. Next, the second roots of the quadratic equation is beta. Express beta in terms of positive powers of rho. Justify your answer. Justify means they want some words there. Okay, so we've got alpha here as a root of this quadratic. The second root is called beta. Now they've made it very clear that the coefficients are real. So therefore the second root, which is alpha bar, the second root should be alpha bar, so beta should be equal to alpha bar. So let's for the justifying, let's start writing. So since the coefficients are real, complex roots occur as conjugate pairs. Complex conjugate pairs. Okay, so therefore beta is equal to alpha bar. So it's going to be rho plus rho squared plus rho to the power of 4 bar. Okay, which we can split up. So that's rho bar plus rho squared bar plus rho to the 4 bar. Okay. Okay, now let's substitute in what rho is. So that's going to be e to the I 2 pi on 7 bar plus e to the I 4 pi on 7 bar plus e to the I 8 pi on 7 bar. And taking the complex conjugate, we change the sign to negative. Okay, now to put this back in terms of rho, I might just go around the unit circle. So I'll add 2 pi to each of these, which is adding 14 pi on 7. So that's going to be 12 pi on 7, adding 14 pi on 7, because we're adding 2 pi. Adding 2 pi, 10 pi on 7, adding 2 pi. Adding 14 to negative 8, we've got 6 pi on 7. Okay, now I can sub back in rho. This will be rho to the power of 6. This will be rho to the power of 5. This will be rho to the power of 3. Okay. So we've got a second root in terms of rho and positive powers of rho. So that's part 2 done. Part 3, find the coefficients of a and b in the quadratic. So So we want to form the quadratic x squared plus ax plus b. And we know that the roots are alpha, which equals to rho plus rho squared plus rho 4, and beta, which is rho 3 plus rho 5 plus rho 6. So what we're going to do to form these coefficients, we're going to use sum and product of roots. So sum of roots should be negative a. Okay, and if I sum the roots, I'll get rho plus rho squared plus rho to the 4 plus rho to the 3 plus rho to the 5 plus rho to the 6 equaling negative a. Now this should look very familiar looking at part A. All these terms are these guys here. Okay, so if I just bring the 1 on that other side, all these guys should equal to negative 1. So that equals to negative 1 equals negative a from part I. So a is 1. Next, to work out the b, we're going to do product of roots. Product of roots is going to be b. Okay, so now we've got to do the product of rho plus rho squared plus rho to the power of 4, rho cubed plus rho to the power of 5 plus rho to the power of 6. Now we've got to expand that. It's going to take us a bit of time to expand. It's going to be a lot of terms here. Start off with rho times by the second bracket. Okay, next rho squared times the second bracket. And lastly, rho to the power of 4 times the second bracket. Okay, now we're going to use the fact that rho to the power of 7 is 1. And we can simplify, we can lower some of these powers. So anything that's 7 rho to the 7, that'll be a 1. This guy we can simplify by using the fact that rho to 7 is 1, so we can, this is rho to the 7 times rho, so it's going to be 1 times rho, so we can just basically minus 7 from the power. Minusing 7 from the power, minusing 7 from the power. Okay, now have a good look at what this is. If you look carefully, there's 2 plus, and then I've got 1 plus rho squared, cubed, power of 4, power of 5, power of 6, which is beautiful because I've got every power there going up to power of 6, and this guy here from part I is equal to 0. So the product of roots, which equals to b, is 2. Okay, so I've worked out that a is 1 and b is 2. Find the value of the coefficients. A is 1, b is 2. I'll just write a is 1 down the bottom. Okay. Next, over the page, deduce that. And then we have this result here. So deduce, meaning we need to look at, use what we've got previously to help us get that result. Okay, we've just formed a quadratic equation which has roots alpha and beta. It's very tempting to solve that quadratic equation. So let's have a look at that. Let's solve it, and we'll see if a root 7 on 2 pops out through the solution. Okay, so that equation has alpha, beta as the solutions. So let's solve this using quadratic formula. Okay. We've got a negative root there, so we need to put the I. I see a root 7 on 2 comes from looking at the imaginary part. Going to call that equation 1. Alright, so we've got a plus and a minus there. the imaginary part of x. Now we know the two solutions to this quadratic equation are alpha and beta. So let's consider alpha. All right, x equal alpha. Okay, and alpha is rho plus rho squared plus rho to the power of 4, and rho was e to the I 2 pi on 7. It'll be 4 pi on 7, and that'll be 8 pi on 7. Okay, so now we're going to consider the imaginary part. So imaginary part, okay, because we got the imaginary part, got the root 7 on 2 that we were after. So the imaginary part of alpha, now that'll be the sine, this angle here, 2 pi on 7 plus sine 4 pi on 7 plus sine 8 pi on 7. Okay, now those angles don't seem to match up exactly with what we're trying to prove. But if we use some properties of sine, yeah, see the different, we want pi on 7. Now convince yourself, negative sine pi on 7, that's going to be this guy, because that guy's third quadrant. Sine 2 pi on 7, well we've got 2 pi on 7, and the other one is sine 3 pi on 7, and that's the related acute angle of 4 pi on 7. So that's sine 2 pi on 7 plus sine 3 pi on 7 minus sine pi on 7. And I'm just going to quote what I've used. I've used that sine pi minus theta is equal to sine theta. Then I've used that sine pi plus theta. That's the quadrant minus sine theta. Okay, so, alright, we're almost there. Okay, so equating 1 and this guy here, we're almost there. The only thing that's left is we need to justify that this must be the positive root, i.e. we have to justify that this is greater than 0. There's a couple of ways to do, but one thing we're going to look at here is that all these angles are in quadrant 1. Yeah, they're all in quadrant 1. And we know that in quadrant 1, sine is positive. You might be wondering there's a negative there. I'll show you how we're going to deal with that negative. So since sine theta greater than 0 for theta between pi on 2 and 0, and sine theta is increasing for 0 less than theta less than sine, I can say that this term here will have to be bigger than this term here because sine theta increases between 0 and 2 pi. So sine 2 pi on 7 has to be greater than sine pi on 7, which means that sine 2 pi on 7 minus sine pi on 7 has to be greater than 0. And if we add this other term that's also in the first quadrant, we get that sine 2 pi on 7 plus sine 3 pi on 7 minus sine pi on 7 is greater than 0. So I've justified why it's greater than 0. Okay, therefore since the imaginary part of alpha is greater than 0 and 1 equals to 2, therefore we have the result. Just equating 1 and 2, we get the result that we were after. That's negative sine pi on 7 plus sine 2 pi on 7 plus sine 3 pi on 7 equals to root 7 on 2 as required. Alright, there you go.